Continuing with our vectors discussion, we're going to take a look at some arithmetic of vectors. Arithmetic of vectors is called linear combinations. So it really just means we're adding, we're subtracting, and we're multiplying those vectors together to create the resulting vectors. I'm not going to draw pictures here. Instead, we're just going to go ahead and do the arithmetic. The important thing to remember is that these are done component-wise. And you're going to see what I mean as I get into the mechanics of this. So we're going to go ahead and take vector u and add vector v. Vector u is 2 comma 4. And I'm going to add vector v, which is -1 comma 1. I'm just going to add this component-wise. So I'm going to add my x's together. So that's going to be a 2 minus 1. And then I add my y's together. That's what I mean by component-wise. So really, really easy. So we end up with 2 minus 1. I can go ahead and write my answer up here, which is 1. 4 plus 1 is 5. Just as easy as that. B, we've got a scalar multiplier here. So this is a scalar of -1. And we saw what scalars do. Scalars change the direction if it's negative, and it also changes the length or magnitude of those vectors. So really though, using some arithmetic, I have a negative sign in front of vector v. In component form, vector v is -1, 1. I'm going to distribute that negative sign component-wise. So we get negative times negative, which is +1. And then negative times +1, which is -1. Notice how I switched the signs on my components, which reverses the direction of this vector. Next, we're going to do u minus v. I'm just going to write this out using my components. So 2 comma 4 minus v, which is -1 comma 1. Using my components, I want 2 minus -1. So 2 minus -1. And then I do the same thing with the y's. I want 4 minus 1. 4 minus 1. You may not even need to write all of this out. A lot of this, because it is arithmetic and it's component-wise, can maybe even be done in your head. So 3 and 4 minus 1 happens to be 3 as well. So we get 3 comma 3. In part D, I have a scalar. My scalar is -3. This one reverses the direction of v, and it makes it 3 times as long. So to come up with the components for -3v, I have my scalar -3 in front of the component form for vector v. I am just distributing. So into those components, -3 times -1 is +3. Notice how that's switching my direction. -3 times 1 is -3. So I get 3, -3. Okay, so just moving right along here, 2u, so 2 times u, 2 comma 4, minus v is -1, 1. I'm going to start by distributing my 2 into the first vector. So that becomes 2 times 2 is 4, 2 times 4 is 8, minus -1, 1. When we do this component-wise, we get 4 minus -1, comma, 8 minus 1. Up to my answer line, 4 minus -1 is 5, 8 minus 1 is 7. Okay, last but not least, I want -u, so -u, 2 comma 4, plus 3, couple of scalars here, v, -1 comma 1. I want to distribute first. Distributing that negative into vector u first changes the signs, -2, -4. Plus, let's distribute that 3, and I get -3, +3. Adding these component-wise, -2 plus -3. Y components, -4 plus 3. So my answer, which is going to be completely lost on that answer line, so I'll write it in black. My answer is -2 minus 3 is -5. -4 plus 3 is -1. And that's all there is to these linear combinations with the vector arithmetic.